Black holes are considered one of the most destructive phenomena in the universe. They tend to distort the laws of physics and swallow entire planets, growing larger as they relentlessly consume anything that crosses their path. What secrets do these awesome forces of nature hold? Could they be a gateway to an alternate dimension? Black holes are some of the strangest and most fascinating objects in space. Albert Einstein first predicted their existence in 1916 in his theory of general relativity. But the term black hole wasn't coined until 1967 by American astronomer John Wheeler. Einstein described these anomalies as points in space where there is such a strong gravitational attraction that not even light can escape their grasp. To put this into context, light travels at around 186,282 miles per second in a vacuum. This means that light can travel around 6 trillion miles in a year. However, in recent years, research has shown that our universe may be expanding by 45 miles per megaparsec, making it faster than the speed of light. Today, it is believed that there could be more than 100 million black holes of varying sizes in the Milky Way alone, but this wasn't always the case. While the existence of these gluttonous beasts was theorized for decades, the first black hole wasn't discovered until 1964, when a sounding rocket detected celestial sources of X-rays in the constellation of Cygnus. It was later determined that X-rays were coming from a bright blue star orbiting a strange dark object. Scientists believed that the detected X-rays were the result of stellar material being stripped away from the bright star and gobbled up by the dark object. The object was named Cygnus X1 and is now considered the first black hole ever discovered. Since that initial discovery, scientists have made significant progress in the detection and study of these phenomena. While they were once considered a theory, it is now believed that black holes are a fundamentally common part of our universe. In fact, a supermassive black hole lies at the center of virtually all large galaxies. The black hole at the center of our galaxy is called Sagittarius A star. It is the point around which everything in the Milky Way orbits. The colossal structure is about 4 million times the mass of the Sun and lies approximately 26,000 light-years away from Earth. Observing Sagittarius A star from Earth is made difficult due to the fact that it is shrouded by a thick screen of intervening dust. According to the Space Telescope Science Institute, approximately 1 out of every 1,000 stars is massive enough to become a black hole. Since the Milky Way contains over 100 billion stars, our home galaxy must harbor some 100 million black holes. The closest one to Earth being the Unicorn, which is situated approximately 1,500 light-years away. It gets its name from the fact that it resides in the constellation Monoceros, which is the Greek word for a mythical horse with one horn. It also alludes to its rarity, as the Unicorn is the only black hole observed so far with a mass only about 3 times that of the Sun. In 2019, NASA was able to capture photographic evidence of these monstrous objects for the very first time. The image was captured by the Event Horizon Telescope collaboration and shows an ominous black hole at the center of the M87 galaxy, 55 million light-years from Earth. These photographs have allowed scientists to confirm long-standing theories about the nature and structure of black holes. It was discovered that all black holes have 3 layers: the outer and inner event horizon and the singularity. The event horizon of a black hole is the boundary around the mouth of the structure. At the event horizon, the escape velocity of an object is equal to the speed of light. Thus, nothing that enters a black hole can get out or be observed from outside this boundary. After the event horizon comes the innermost region of a black hole, where the object's mass lies. It is known as its singularity. It is the single point in space-time where the mass of the black hole is concentrated. While all black holes have the same structure, scientists have found that they may take different paths to formation. So far, astronomers have identified 3 types of black holes: stellar black holes, supermassive black holes, and intermediate black holes. When a star burns through the last of its fuel, the object may collapse or fall into itself. For smaller stars, the new core will become a neutron star or a white dwarf. But when a larger star collapses, it continues to compress and creates a stellar black hole. Black holes formed by the collapse of individual stars are relatively small, but incredibly dense. Just one of these objects packs more than 3 times the mass of the Sun into the diameter of a city. This leads to a crazy amount of gravitational force that pulls other objects around the black hole towards its center. Stellar black holes then consume the dust and gas from their surrounding galaxies, which keeps them growing in size. Small black holes populate the universe, but their cousins, supermassive black holes, dominate. These enormous black holes are millions or even billions of times as massive as the Sun, but are about the same size in diameter. Scientists aren't certain how such large black holes spawn. One theory states that they gather mass from the dust and gas around them, material that is plentiful in the center of galaxies, allowing them to grow to even more enormous sizes. Supermassive black holes could also be the result of hundreds or thousands of tiny black holes that merge. Dark matter could also be a culprit in the formation of these destructive maws. This is a substance that we can observe through its gravitational effect on other objects. However, we don't know what dark matter is composed of because it does not emit light and cannot be directly observed. Scientists once thought that black holes came in only small and large sizes, but research has revealed the possibility that mid-size or intermediate black holes could exist. Such bodies could form when stars in a cluster collide in a chain reaction. Several of these IMBHs forming in the same region could then eventually fall together in the center of a galaxy and create a supermassive black hole. In 2014, astronomers found what appeared to be an intermediate mass black hole in the arm of a spiral galaxy. Research from 2018 suggested that these IMBHs may exist in the heart of dwarf galaxies all over the universe. Observations of 10 such galaxies revealed X-ray activity, suggesting the presence of black holes ranging from 36,000 to 316,000 solar masses. The information came from the Sloan Digital Sky Survey, which examines about 1 million galaxies and could detect the kind of light often observed emanating from black holes that are picking up nearby debris. Regardless of its size, nothing can escape the grasp of a black hole. Thus, no one knows what truly exists inside the event horizon. However, decades of research have finally yielded a number of theories that could finally solve the mystery. According to some calculations, what the fabric of space-time looks like inside a black hole depends on that particular black hole's history. It might be turbulent, twisted, or any other number of things. The singularity at the center of a black hole is the ultimate no man's land. A place where matter is compressed down to an infinitely tiny point, and all conceptions of time and space completely break down. Put simply, singularities are instances in physics and mathematics where laws misbehave, typically by generating infinitely large values. This behavior points towards the fact that a theory has broken down and needs to be replaced by a better understanding of the subject. As with all singularities, a better explanation is needed for what exists at the center of a black hole. We just don't know what that may be yet. It could be that deep inside a black hole, matter doesn't get squished down to an infinitely tiny point. Instead, there could be the smallest possible configuration of matter, the tiniest possible pocket of volume. This is called a Planck star, and it's a theoretical possibility envisioned by loop quantum gravity, which is itself a highly hypothetical proposal for creating a quantum version of gravity. However, this theory is still in its infancy and is not yet fully supported by physicists. Over the years, we have seen many instances in sci-fi TV shows that a black hole may be a gateway of sorts that leads to another dimension. The idea may seem far-fetched, but the truth of the matter is that it is a mathematical possibility, even if it is quite small. In theory, a black hole may be paired with a mirror twin called a white hole to form a wormhole. Still, these theoretical wormholes would look nothing like the ones depicted in science fiction. Traditional wormholes are predicted to be incredibly unstable, meaning they'd collapse the moment a single particle of matter entered them. Some physicists predict that a wormhole could become more stable if it was formed from a spinning black hole, but our understanding of what happens in that scenario is murky at best. A new theory from the University of Michigan may be the closest thing we have to an answer. It states that black holes can be classified as holograms. The study, headed by Enrico Rinaldi, is based upon an idea known as holographic duality. This states that the theory of gravity and the theory of particles are mathematically the same. However, the theory of gravity describes the third dimension, while particle theory describes the second. As far as black holes go, both of these theories are relevant in describing how they operate. The study, headed by Rinaldi, investigated what this holographic duality idea means for black holes and what's inside of them. The study points out that our concept of the inside of a black hole is based on the theory of gravity, which suggests that it operates in the third dimension. Space-time moves into and through a black hole from the outside. However, the outside of a black hole isn't calculated the same way as the inside. The outside of a black hole is perceived as flat, despite the inside operating in 3D. The latest research by Rinaldi uses two simulation methods at the same time to ultimately calculate and describe what the gravity of a black hole looks like. Rinaldi suggests that the best way we can perceive what's happening inside a black hole is by way of a holographic projection. Using quantum matrix models to study the connection between the theory of gravity and particle theory, researchers have described a black hole with a three-dimensional center that we see projected to us courtesy of particles that are calculated in 2 dimensions. Again, according to these calculations, the inside of a black hole can only currently be described mathematically. Until we possess the ability to perceive the inside of a black hole in a way that doesn't mesh with our current understanding of the nature of the universe, we won't really truly be sure if what we're seeing is all there is to see in 2D, 3D, or beyond. Until then, all we can do is speculate about the malicious nature of these objects. Are black holes nothing but an awesome force of destruction? Or could they be a portal to another universe teeming with life? What do you think? Let us know in the comments section below.